Embarking on a journey to Mars presents formidable challenges. Not only due to the vast distance ranging from approximately 56 million kilometers 35 million miles at closest approach to nearly 400 million kilometers 250 million miles when Earth and Mars are on opposite sides of the Sun, but also because of the harsh conditions awaiting any crew upon arrival. Mars, the fourth planet from the Sun, is a cold, desert-like world with a very thin atmosphere. To mitigate the prolonged exposure to space radiation and microgravity inherent in such lengthy voyages, NASA is exploring advanced propulsion technologies to expedite travel times. One promising avenue is nuclear electric propulsion (NEP), which utilizes a nuclear reactor to generate electricity. This electricity ionizes and accelerates gaseous propellants, producing thrust to propel a spacecraft. Researchers at NASA's Langley Research Center in Hampton, Virginia, are developing a system to advance NEP technology significantly. The project, known as Modular Assembled Radiators for Nuclear Electric Propulsion Vehicles, MARVL, focuses on a critical component of NEP systems, the heat dissipation mechanism. By dividing this system into smaller modules that can be assembled robotically and autonomously in space, MARVL aims to overcome the limitations of fitting large structures into rocket fairings. Amanda Stark, a heat transfer engineer at NASA Langley and the principal investigator for MARVL, explains, "By doing that, we eliminate trying to fit the whole system into one rocket fairing. In turn, that allows us to loosen up the design a little bit and really optimize it." Traditionally, integrating an entire NEP radiator system within a single rocket fairing posed significant challenges. Fully deployed, such a radiator array would be approximately the size of a football field, making it difficult to compactly stow within a rocket's nose cone. The MARVL approach offers greater flexibility, allowing components to be sent into space separately and assembled in orbit. Once in space, robots would connect the NEP system's radiator panels, through which a liquid metal coolant, such as a sodium-potassium alloy, would flow. This method leverages decades of in-space assembly expertise at NASA Langley and represents a shift toward designing spacecraft with in-space assembly in mind. Julia Klein, a mentor for the project in NASA Langley's research directorate, notes, "Existing vehicles have not previously considered in-space assembly during the design process, so we have the opportunity here to say, we're going to build this vehicle in space. How do we do it? And what does the vehicle look like if we do that? I think it's going to expand what we think of when it comes to nuclear propulsion." The MARVL project, funded through NASA's Space Technology Mission Directorate's Early Career Initiative, has a 2-year timeline to advance the concept. The team is collaborating with external partner Boyd Lancaster Inc., as well as radiator design engineers from NASA's Glenn Research Center in Cleveland and fluid engineers from NASA's Kennedy Space Center in Florida. The goal is to progress to a small-scale ground demonstration after 2 years. The concept of robotically assembling a nuclear propulsion system in space is inspiring for many involved. Stark shares, "One of our mentors remarked, 'This is why I wanted to work at NASA, for projects like this, which is awesome because I am so happy to be involved with it, and I feel the same way.'" As NASA continues to develop NEP technologies like MARVL, the prospect of faster, more efficient missions to Mars becomes increasingly attainable. This progress not only shortens travel times, but also reduces the risks associated with prolonged space travel, bringing the goal of human exploration of Mars closer to reality. Mars, often referred to as the Red Planet due to its reddish appearance in the night sky, has been a subject of human fascination for centuries. It is the 7th largest planet in our solar system and has a diameter of about 6,779 kilometers, 4,212 miles. making it roughly half the size of Earth. The Martian atmosphere is composed primarily of carbon dioxide, about 95.3%, with traces of nitrogen and argon. This thin atmosphere contributes to the planet's cold temperatures, with an average surface temperature of about -63 degrees Celsius, -81 degrees Fahrenheit. However, temperatures can vary widely, ranging from -143 degrees Celsius, -225 degrees Fahrenheit at the poles during winter, to up to 35 degrees Celsius, 95 degrees Fahrenheit in equatorial regions during midday in the summer. Mars' surface features include the largest volcano in the solar system, Olympus Mons, which stands about 22 kilometers, 13.6 miles high, and the deepest canyon, Valles Marineris, which stretches over 4,000 kilometers, 2,500 miles long, and reaches depths of up to 7 kilometers, 4.3 miles. Recent discoveries have provided compelling evidence that liquid water once existed on Mars. For instance, data from China's Zhurong rover, which landed in Mars' northern lowlands in 2021, revealed rock formations indicative of ancient shorelines, suggesting the presence of a prehistoric ocean around 3.68 billion years ago. Additionally, seismic data from NASA's InSight lander indicate significant amounts of water may be trapped in the Martian crust, potentially forming an underground ocean. These findings not only enhance our understanding of Mars' geological history, but also have significant implications for future human exploration. The presence of subsurface water could be a vital resource for astronauts, providing water for drinking, oxygen for breathing, and hydrogen for fuel. However, accessing this water presents challenges, as it is located deep beneath the surface. The development of advanced propulsion technologies like NEP is crucial for enabling human missions to Mars. By reducing travel time, NEP can help limit astronauts' exposure to harmful cosmic radiation, which is a major concern for interplanetary missions. Unlike Earth's atmosphere and magnetic field, which provide protection from space radiation, Mars has no global magnetic field, leaving its surface exposed to high levels of cosmic rays and solar radiation. Long-term exposure to such radiation can increase the risk of cancer and other health issues. NASA's current estimates suggest that a round-trip journey to Mars using traditional chemical propulsion could expose astronauts to radiation doses exceeding established safety limits. By shortening the trip duration, NEP technology could mitigate this risk, making Mars missions safer and more viable. In addition to radiation concerns, microgravity poses another significant challenge for Mars missions. Extended exposure to microgravity can lead to muscle atrophy, bone density loss, and cardiovascular deconditioning. Reducing travel time through advanced propulsion methods like NEP could minimize these adverse effects, ensuring astronauts arrive on Mars in better physical condition. Furthermore, a faster propulsion system would allow for increased cargo capacity, enabling the transport of essential supplies, scientific instruments, and habitat modules needed for long-duration missions. This would pave the way for sustainable human presence on Mars, supporting both exploration and potential colonization efforts. NASA's continued research into NEP, including the MARVL project, represents a pivotal step toward realizing the dream of human exploration beyond Earth. By leveraging nuclear power, robotic assembly, and innovative engineering, NEP could revolutionize space travel, making interplanetary missions faster, safer, and more efficient. With each technological breakthrough, the vision of sending astronauts to Mars becomes less of a distant dream and more of an imminent reality. The development of nuclear propulsion not only advances our ability to explore the red planet, but also lays the groundwork for future missions to even more distant worlds, heralding a new era of deep space exploration. If you enjoyed this deep dive into space and science, don't forget to hit the like button, subscribe for more amazing content, and share your thoughts in the comments. Help us spread the wonders of the universe. Share this video with friends who love exploring the unknown.